Hi, I'm Vasudha, and the project that I've been assigned to is to create a real time crypto price tracker. So, I will be walking through my thought process, the implementation, and the output. So, speaking of my thought process, initially when I read the problem statement, it is about how you render real time crypto prices onto the website. So, it is obvious that the state of the crypto data changes each and every second, and we have to manage that state, and using Redux for the state management is optimal. So initially, this is the main entry point to the React app, that is index.js. So we will import provider from React Redux, and we will wrap our app within this provider so that the store that we created is accessible to all of the components within our app. So now let's see what the store is. So the Redux store is nothing but a central object that maintains the global state of the application. So we will be defining a store by using the configure store from Redux toolkit, and here we'll be defining a reducer as well. So for the state crypto, we will be importing the crypto reducer from a file called crypto slice. A slice is nothing but an app's portion that manages the state. So there can be different slices, like for example, this crypto slice manages the crypto related state, and there can be other slices like auth slice, which can manage the authentication. So let's look on how to create a slice. So we'll create a slice using create slice from Redux.js toolkit, and the parameters are name, the name of the state, and an initial state. So initially the state is empty, and we will be appending data to it as we run the application. Then there are reducers. So reducers are nothing but functions that take the current state and an action that needs to be performed on the state, and they will perform this action on the state in order to change the state. So here we have the first reducer, that is set crypto data, which will set the crypto data to the latest data that we get. So it has two parameters, state and action. So it will first read the action dot payload, which is nothing but the data that is being passed down to it. Payload is the data. And this line called state dot assets of symbol equal to data means we're setting the data that we got into our assets. So this assets is the data that we use in order to render onto the screen. So we'll see where we're getting this data from in order to gain more insights into this. So this is the table file that gets rendered onto the application. So initially we'll define some symbols for which we will be rendering the data. Okay, so for this application, what I did is I used Binance WebSocket in order to get real-time updates for price, percentage change 24 hours, and volume 24 hours. The rest of the parameters are mock data, which I defined here, and these will be used in order to re-render the updates. So we'll be having a dispatcher in order to call the reducer function that we defined earlier. We will be using this use selector in order to gain access to the data that is being stored in the state. And this line is the usage of the useref hook on WebSockets, because we do not want the WebSockets to get recreated every time the screen re-renders. So this holds a reference to the main WebSocket element. So once this WebSocket receives a message every 1 or 2 seconds from the Binance WebSocket, what we'll do is we will parse through the data and we'll get the price, percentage change 24-hour, and volume 24-hour. The rest of the data, like percentage change 1 hour, 7 days, will be simulated using math.random. And the images and the charts that I used, we will be getting it from the mock data that I defined. The percentage change fields, volume 24-hour field, and the price fields are the only ones that needed to be changed. So what we'll be using is we'll be using a mock constant value using math.random again in order to fill the circulating supply and the max supply field so that they don't get re-rendered every time, and I defined it in the metadata. So once we open the application, this use effect will run once since it has an empty dependency array, and it will call the create WebSocket. And this is a cleanup function. Whenever we return from the application, this reference will be cleaned up. Now, this is the main UI return function. So we will be defining a table with the following headings. So we will apply a map function to the symbols, and we will get the current coin and its data. So once we got the data, we will be using tr in order to render to the row, and td in order to fill the cells within that row. And similarly, all other rows are rendered as well for each coin or symbol that we get. And this is a whole UI that gets rendered on the website, and this will be wrapped inside app.js and will return that component. So this is the overall UI, and we have a logo column here which will display the logo of each coin that we get and their particular name and the symbol. So the price, 24-hour percentage change, and 24-hour volume are the real-time data that we're getting from the Binance WebSocket. As you can see, they get changed every 1 or 2 seconds. And the percentage changes in 1 hour and 7 days are simulated using mock data. And as you can see, if the percentage change is less than zero, a red color will be rendered, and if it's greater than zero, a green color will be rendered. As you can see, the market capital and the circulating supply do not change because it's not mentioned in the problem statement. But if you want to change it, we can also add it within the simulating function that we're calling using dispatch. And then you can also see the 70 chart. All of these are static images that I got from website.